All right, we are looking at measures of variability today on our project. This is, remember, a test grade over the data and statistics unit. So what we are going to do is, yesterday we collected all the data from our activity we did on Friday. So I put it in a data table for you. It was in numerical order. It is not anymore because we had to add those three numbers. So you're going to want to change that and put them in numerical order. So what we've got is, you guys don't have access to change, do you? I didn't think so. Okay. We're going to remember what does variability mean anyways? When I say measures of variability, what does that mean? You don't remember? What does it mean, people? Measures of variability. Get your hands off the computers and pay attention to me, because I had to explain several times to the first period because they didn't pay attention when I went through it the first time. All right, so measures of variability. Think you know now? Right, the difference in the biggest and smallest numbers, that would be the range. So how spread out is the data, right? That's variability. So we use the interquartile range and our just range of the overall of the data. So what we're going to do is we are going to take all of these data points for each class, and we're going to create box and whiskers and make comparative inferences between the classes and their graphs. So here's how it works. I broke it down into steps. Step one is to take all your data here, break them up into 4 equal quartiles. Then we're going to put those into a Google Sheet to create the box plots. So here's what we have. Here's what it's going to look like. You're going to end up on a piece of paper, write out first period, identify the lower extreme, quarter 1, quarter 3, and upper extreme. Do that for all the classes. Then you're going to create your box plots by using this setup. This is important, everybody. Step 2, this data is not correct. I just put examples in there. You're going to put whatever you get for each class on those parts in this table. You're then going to take and go to a Google Sheet, and you're going to get rid of, you're going to take a Google Sheet and you're going to put this table in the Google Sheet. Everybody with me so far? You're going to have it set up just like this. Because if you don't have it set up just like this in the Google Sheet, it's going to make it difficult to create your box plots. So now, everybody stay with me. Hands off the computers. Pay attention so you know exactly how to create it when you get this far. I'm going to highlight my table. I go up to Insert, Chart. Its default is this column chart. We don't want that. So over on Chart Type, I'm going to click this and scroll down till I see a picture of the box and whiskers. They call them candlestick charts. So I click on that, and that does not look right, does it? You want to know why it doesn't look right? Because it's not reading the first row, or it's reading them wrong, backwards. So I need to switch rows and columns. And boom. Now it gives me comparative box charts, box plots. Once I get this far, I click on my box plot. Click on my box plot. Right here, I'm going to copy chart and put it in a Google Doc. Okay? You can do the Google Doc you started yesterday for those that started one yesterday. If you did not start one yesterday, start a new one. Call it your data and statistics project, whatever. So copy and paste this in there. Once you get that in there, a Google Doc, you're going to go back to, what happened to my data in that spot? No. Was it just 0? So it's -5,0,0,5,5,5,3,5s. So it's supposed to be a 5 in that. Oh, is there a 5 in there? Yeah, there was a 5. Sorry. All right. So we come back over here. And then we go to step 3. Identify the variability. So we calculate and record the range, IQR, in my Google Doc. So underneath the chart, just say the range for this class is this, the IQR is this for each class. We're going to make a conclusion. We're going to compare the variability between all the classes. If you're not sure, don't remember what those statements were like, go back to the homework on measures of variability and look at where they made statements and come up with something similar. And then step 5, you're going to tell me which class was better at the Mr. Bouncy Challenge and why. Okay, so let's go back to my chart here and tell me, what statement of variability can I make based on my data right here? Now, your data is going to look different. This is just an example. What can I conclude about the variability between the classes here? No? 4 or 5 period has the largest range. It's got the largest interquartile range, right? It's got the largest box in the middle, that middle 50%. What? What about second period? You got the largest range? Nope, not the largest range. Because when I hover over it, tells me lower extreme to upper extreme. You can see all those different parts that we put in there. Elizabeth? 6-7. What about 6-7? Does it have the largest range? So that's a range of 260. Nope, ninth period has the largest range. It's got 270. Yep, this one's got the largest range. However, I'm making comparative conclusion based on this. So remember, variability, one of the most common comparative conclusions, inferences you can make is which class is more consistent? Remember, it's more of a statement of consistency. So which class would you say is the most consistent? Which class would you say is least consistent? 4-5 is what? Most consistent? Now, I wouldn't say that. I would say it's one of the least consistent because the box is the largest. Alice? Second period is what? The most consistent, because the interquartile range, that box, is the smallest. We don't want a big spread to be consistent. We want a smaller spread for it to be consistent. So we would say, which class would be the least consistent then? Lorelai? 4 or 5? Now its overall range is not the largest, but the interquartile range is the most, right? So you can use the interquartile range, that middle 50%, to justify your reasoning there. Okay, which class would you say was the best at the Mr. Bouncy Challenge? What? Of course you're going to say second, because you're in second. What's the highest score in second period? 120. Did somebody get 165 in here? Well, you didn't tell me that yesterday when I recorded the results. Oh, there is. Oh, yeah, there's a. Sorry. See, this, I forgot. My table, my graphs are not reflective of the actual scores, right? So based on my scores, not the actual scores, which class would you say is the best at the Mr. Bouncy Challenge? Probably 6, 7. They not only have the highest score, but you can see that generally they're up there. Their top 25% is up there with this class, but a little bit higher, right? So you'd have to have some sort of reasoning as to why you think that. And I would say the top 25% is above everybody else's. Okay? So let me get you started on what this looks like. So get out a blank piece of paper. All right, so what we are going to do, step 1, is we're taking all of our data and breaking it up into the 4 equal parts so then we can put it in our table, right? So what I'm going to do is I'm going to take this first row and I want to list my numbers out. So somebody tell me, what is the smallest number on that? Negative 190. Next one. 135. Next one. And another 60. All right. So the lower extreme is my smallest number. So I plug that in the lower extreme. My upper extreme is the largest number, 60. So I plug that in there. Now my quarter 1 and my quarter 3 are the tricky parts. Remember, when we did this before, we also found the median. But the Google Sheets doesn't recognize the median, so we didn't put that in our data table. However, we need to find the median in order to find the quarter 1 and quarter 3. So we want to break this data in half. So what's my median? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12 numbers. So 1, 2, 3, 4, 5, 6. My median falls between those two tens, right? That gives me 6 numbers on the bottom and 6 numbers on the top. So Q1 is cutting the bottom half in half. So if there's 6 numbers down there and I cut it in half, My Q1 is going to be right there between negative 40 and negative 20, right? What number falls between negative 40 and negative 20? Negative 30. You can always just add these two numbers up and divide by 2. Negative 40 plus negative 20 is negative 60 divided by 2. That's negative 30. My quarter 3 is cutting my top 6 in half. So that would be right there. So what number falls between 25 and 60? Well, add them up. That's 85 divided by 2. That would be 42.5. And then once I get that done for all 4 classes, I can create that data table that I have an example of in my Google Sheet and use that to create my box plots. Okay? So there you go. I got you started. I'm going to turn you loose. If you get confused, forget how to do something or what I was saying earlier, this video's in Google Classroom. You can always go back and refer to it on the different parts and how to create